Welcome to the pH and Titratable Acidity Laboratory and also the preparation of standard solutions. So in today's lab we're going to actually learn 4 different procedures, and we're going to be starting with procedure 1, which is where we're going to actually prepare a 0.1 normal sodium hydroxide solution. So I have my bottle all ready here, and I prepared before class a 25% sodium hydroxide solution. The reason I did this is because you would have received it as 25% solution, and also when you add the sodium hydroxide pellets to the water, it's exothermic, so it gets quite hot. So it actually takes some time to get the volume just right and for it to cool down, and then you bring it to volume. So your instructions tell you to use 750 mils of carbon dioxide free water, and to that you're going to add 12 mils of this sodium hydroxide solution. Here I have actually prepared 2 flasks of carbon dioxide free water. And what makes it carbon dioxide free is it's been boiled for 15 minutes, and as it's boiling, any gases that are in the water boil off, and then you take it off the hot plate and you put a stopper on and you attach a trap, and inside of this syringe is this compound called ascarite. And what ascarite is a silica coated with sodium hydroxide, so that carbon dioxide will any residual carbon dioxide would react with the sodium hydroxide, and so it's a way of trapping and keeping it carbon dioxide free. And we'll talk about why you have to have a carbon dioxide free water as we go on. Plus also Pam will talk about it in the introduction. Okay, so the first thing I'm going to do is I'm going to actually measure out 750 mils of this special water. And I have a 1 liter flask here. Yep, 750 mils into here. And although I have it labeled as 0.1 normal sodium hydroxide, I don't know for sure that that's the way it's going to turn out. So we're going to actually standardize this. This is something that if you work in a research lab or if you go on and work in industry, you'll get a lot of experience working with standardized solutions. And now I'm going to, it tells me, instructions say to add 12 mils of 25% sodium hydroxide. So I've got my pipette here, and I'm going to just transfer some of this into here. And then if you were in the lab class at this point, anything that would be left here of the 25% sodium hydroxide is actually considered hazardous waste. So we would have a special bottle for you to put it in. So I'm going to just actually set it aside here for now.
And here we can just see that Cindy is mixing her sodium hydroxide solution really well before we go to standardize.
And we are going to standardize this. Rachel has a lot of experience creating standardized solutions. But the reason why you have to standardize this is because sodium hydroxide is hygroscopic, meaning it'll absorb water. And if it absorbs water, when you weigh out a certain amount to make like a 25% solution, you won't necessarily have that amount. So what we use is an acid called potassium acid phthalate. This is step 4 on the procedure, where we're going to standardize NaOH. And we're going to weigh out 0.8 grams of this dried potassium acid phthalate into each of 3 250 ml Erlenmeyer flasks. And then we'll record the exact weight in this Excel sheet that you guys will receive. I've weighed 2 of them out already, and so you'll just watch me weigh the last one out. And I have 0.8, that's fairly impressive, 0.8000 grams, okay? And then I will transfer that into my flask here. And now I'm done with this. So now we're going to move over to this other side, and the procedure says at this point now we're going to add 50 mils of the carbon dioxide free water. So I'm going to take my flask, my giant flask over here, and you'll use this for some other things too. And I have a 50 mil graduated cylinder, so I'm just going to add 50 mils of this to each of these 3 flasks. So I've added my 50 mils of water to each of these flasks. And the next step that you do is you're going to, it says to gently swirl until the sample is dissolved, and then you're going to add 3 drops of phenolphthalein indicator and then titrate against a white background. So we have our white background, and I'm going to need to fill my burette with my sodium hydroxide that I've prepared, that I am not completely sure what the concentration is, so we're hoping it's close to 0.1. Remember, you are going to add some to just kind of rinse the inside of the burette out. Okay, so I've swirled it till it's pretty well dissolved, and then I'm going to add 3 drops of phenolphthalein to this. Now we're ready to titrate. So the burette is filled, and now I'm going to, I'll start with replication number 1. Set this to the side, and I'm just going to add drops until I get to, and I think we can just show them one good titration, don't you think? Show through. So what's happening here is the acid, the potassium acid phthalate will react with the sodium hydroxide, and Pam will go into a detailed explanation of the reaction itself, and plus also it's in your lab manual that describes it. And so and you just keep on adding until you start to see a color change. And we're going for that light pink, which is indicative of I guess a pH like 8.2, which is the pH which the phenolphthalein should show up. So that's what it looks like if it's greater than pH 8.2. It's just shot past the titration. And that was at 18.3 mils plus 25. So 25 plus 18.3. Okay, so now we're having a little bit of a change. And Rachel's actually has more experience titrating. And I'm going to have her titrate the second and the third. I titrated about 43 mils to give that beautiful, I guess that chartreuse pink color. So I'm guessing that it's going to be probably closer to 40 mils this time. So she's going to go through and titrate, and when we get close to 40 mils, I will turn the camera back on. Okay, so this is our second replication, and Rachel is titrating it, and she is watching for that, just like that perfect point on where to stop, where you get the light pink indicating that you're at pH 8.2. Okay, she is almost there. Now Rachel tells me her technique is at this point, once you start getting really close, you just do a drip, drip, drip. There, I think you're there.
Pink, but...
Yep, so that's that. So it's lighter than the one that I did, and we will accept that as the beautiful, perfect pink. Okay, so these are our 3 replications, and it's really interesting. It was just the difference between the second and the third reps was like less than a drop according to Rachel. So after you finish that, you'll record your data. You'll record the volume of the titrant, which was 43, 43.9, and 43.3. And then you have the weight of the potassium acid phthalate. And then you'll use an equation from your book, and you'll calculate the normality of the NaOH. You'll take an average and a standard deviation. So now we're going to go on to the next step in the procedure. So now for step 5, what it has you doing is actually standardizing HCl. And you're supposed to come up with a procedure that you will use for standardizing it. And Rachel and I chose measuring out 25 mils of what we think is 0.1 normal HCl, and then she's going to use the sodium hydroxide that we just standardized and we now have determined the normality of, to actually determine the normality of the HCl. It's a sequential thing. So again, she's going to put 3 drops of phenolphthalein into the flask, and then she's going to begin the titration. You can almost kind of guess how much volume it would actually take, because if we're using 0.1 normal sodium hydroxide to titrate 0.1 normal HCl, it's probably going to be pretty close to the same volume. Okay, so now she'll begin the titration. She put 3 drops of phenolphthalein, and she's just going to add sodium hydroxide until we reach the end point, which is approximately pH 8.2, and that's where the phenolphthalein turns to a light pink. Okay, so now she'll, it was 25 mils of HCl and 28.1. And then she'll end up calculating the normality. And then we'll do rep 2 and 3, and then you will actually get this data on Monday or Wednesday. Okay, so Rachel has finished the titrations of the 0.1 normal HCl, and then she has recorded the volumes required to titrate, and then there will be a calculation done to actually determine the real concentration of that HCl, and that would be considered a standardized solution that you would use for some research purpose. So now we're going to move on to the next procedure in the lab manual. And the next procedure is, now we're moving into titratable acidity. And we're going to be looking at the titratable acidity of 7-Up, boiled and unboiled, and then also apple juice. Okay? And so Rachel's, the procedure has you pipetting 20 mils of 7-Up into each of these flasks. And then for the boiled 7-Up, you will put the flask onto a hot plate, and it says that you're going to boil it for 30 to 60 seconds. So we'll bring it to boil. Okay, so then she'll take the two flasks over to the hot plate when she's done, and she will put them on to boil. This is actually going to have an impact on your titration, and this is a great exercise on understanding the impact of carbon dioxide on titratable acidity. So now we have 4 flasks, and your instructions at this point tell you to add, I think you're going to be adding to this 3 drops of 1% phenolphthalein, and then that's that. You're not going to add any water to it. So just 3 drops. And so there's our faithful phenolphthalein solution. And there she goes. She puts 3 drops. There's definitely no color, so that means it's an acidic pH. So, okay, so now we are on step 2 with the boiled soda. She added the 3 drops to the unboiled. And for the boiled soda, for step 2, it instructs you to add 50 mils of CO2-free water to that. Okay? And so she will add that to each of the 250 ml flasks. Okay, so now we have all our samples, and we're ready to go. We have 2 boiled flasks, which are labeled in green, and we have 2 unboiled flasks. So now we're going to go back to the burette station that has the sodium hydroxide, because actually for all of the titrations today, you're titrating with this standardized sodium hydroxide. So she's all set. She's got the phenolphthalein in there. So she's decided she wants to do the unboiled first. So the first thing she has to do is fill her burette back up to the 0 mark. And I predict that because the soda has citric acid in it, it's going to, it's acting as a buffering agent right there, and it's going to behave differently than the 0.1 normal, so when it starts to change, it won't suddenly just jump to that deep pink. What do you think, Rachel?
I hope so.
Yeah, at least that's what Pam said it should do in lecture the other day. So we're going to test her what she taught you. Okay, so she's just going along, and actually I can actually see some pink starting to develop. Now what your instructions tell you to do is you're supposed to titrate until it's at light pink, and then you're supposed to observe if the color fades, and you would record this in your lab notebook. Is the color stable or does it fade? So once she gets to her endpoint of pH 8.2, which she's very close now, you usually want to wait like a few, like 30 seconds. Is that correct?
Yeah.
And then to make sure it holds, and then that's the volume you would record. Now she's doing it a little drop at a time because the experience with the HCl was one drop went from light pink to chartreuse. So that is light pink. So let's see if it disappears with time. I'm going to go from a different angle because I think it needs a little more.
Yeah.
Yeah.
It disappeared.
It didn't hold. So now she's going to add a little more. She's going to time it and see if it holds. Okay, so that's it. We did one. Okay, so this is the unboiled soda, and rep 1 is on the left, rep 2 is on the right, and I'm going to just turn this around so you can see it. And what's interesting about it is if you look at rep 1 on the left, you can see it's lost all of its color because of the carbonation that is still present. It continues to react with the sodium hydroxide, and the unboiled on the left is pink, and with time that color will disappear. So if you were doing this lab, you would actually record this. Okay, so here you see the 3 replications of the unboiled soda, and replication 1 is completely colorless. Replication 2 has almost lost all of its color, and replication 3 was just done, and it had a stable pink, light pink color for 30 seconds, and Rachel recorded that volume. So now we are done with the unboiled, and now we're actually going to look at what happens to the titratable acidity when you boil it. So now she'll go ahead and titrate the boiled 7-Up. And so this is the boiled, and she's timing 30 seconds now, and then she will record that volume, and then we'll actually go back and we'll compare that to the unboiled when she's all done with the titrations. Okay, this is her second rep. That looks beautiful. So now she's timing it for 30 seconds. And so then this is rep 1. Rep 1, as you can see, hasn't lost any color yet. So it's a stable pink color. And that's the noteworthy point.
Okay, that's 30 seconds.
And just as a refresher, that's what the unboiled looked like. It lost all of its color, and the boiled retained its color. Okay, so for the very last procedure for titratable acidity, we're actually going to be looking at apple juice. And apple juice contains a different organic acid than the 7-Up. It contains malic acid, and Pam talked about this in class too. So what Rachel is doing is following the instructions, and it says to add 20 mils to 3 different flasks, and the flasks will be labeled A, B, and C. And she'll put the 20 mils into A. And then the instructions tell you to add 50 mils of the carbon dioxide-free water to each of the flasks. And flask A will be used as our reference flask. We'll observe the color of it, and that's it. Nothing will be done to it. It'll just be the starting point as a color. Because, you know, we're looking at color change with the phenolphthalein, and so the color will be a little bit different because it'll be influenced by the initial color plus some other stuff. Okay, so now she's adding her 50 mils to each of the flasks. So now we have flasks A, B, and C ready, and your instructions tell you to determine the pH of these solutions at the start. And we're going to actually be using flask beaker number C as our beaker for measuring pH. And she just put the phenolphthalein into the apple juice, and she only put it into beaker C. Okay, so over here is our pH meter, and it's already been standardized. So she'll just rinse off the electrode and then blot off the extra water after it's rinsed, and then she will just put the electrode into the solution, and we will get a reading. The pH of that is 3.62, and then she'll type it in as the initial pH. Okay, so now what she'll do is rinse the electrode off, and then kind of store it, and then begin the titration. Okay, so now the titration is beginning. So she's just going to add a mil to each beaker and then stop, swirl it around. And now what she'll do is she'll bring beaker C over and measure the pH, and then type that in. And this time it is 3.87. Okay. And then she'll titrate another mil, and this will just be repeated 1 mil at a time. The table actually has you titrating up to 20 mils. We'll see how far we go. What we want to do is create a plot that allows you to see the change in pH and the pKa, where you've got the 50% of the I guess that carboxyl group is protonated and unprotonated, and you see a little delay in increase in pH as more of the sodium hydroxide is added, and that's how it shows that it's buffering. So here's what, I don't know if you can see this very well. Here's A. That's what it should look like when she started. And then by adding the base, that's all that was added was base, we end up with B. That's quite a bit different in color. And then when you add the phenolphthalein, just as an indicator, that's all it's used for. You can see when you're above pH 8, you've got that pink. And then what you're actually going to do is you will be plotting, I believe that it is pH on the y-axis and volume on the x-axis. So now she's adding another mil. That makes 11 mils. So the last thing we're going to do is we're just going to compare the three solutions and see where we ended up color-wise. So we started out with A, that's what the apple juice looked like, then it went to B, and then C with the phenolphthalein. So between A and B is the impact of pH alone on the pigmentation in the apple juice, which you will learn about. And that's it for this lab. So there will be, you'll actually end up plotting this data, and you will get this data as a data set, and then we'll be working with it in the virtual lab. And that's it for today. Thanks for your patience.